All right, so on the picture shows two price tags for two different salad dressings at the store. Which salad dressing offers the better deal and why? So what do you think? Just say it. Yep.
I think salad dressing too.
And why?
Because it has the unit rate for like the amount per ounce is less than salad dressing 1, and it's more ounces in salad dressing 2.
Good job. Yes, so salad dressing 2. Good vocab that we're about to learn. Yes, so the unit rate is perfect. If you're looking at the price per ounce, which is right there, focus, it is cheaper. So this one's 12 cents per ounce, this is 9 cents per ounce. So it's kind of hard to like compare if you don't have that value. Just looking at $3.89 for 32 ounces, $4.29 for 48 ounces, our brains don't really work like that. But if we look at the price per 1 ounce, we can see, okay? So it's cheaper per ounce. And if you go, I don't know if any of you guys like go grocery shopping with somebody at home or whatever, if you look at the tags, like the price tags, you'll notice it in the corner that it'll have the unit rate price, okay, so you can compare. And if you start really looking at those, whenever I started looking at this, you'd be kind of surprised how many things are advertised to be like a better deal, like buying in bulk, like big family-sized chips versus normal-sized chips that actually aren't a better deal for buying more of them, okay? So just kind of pay attention to stuff. All right, so this is me, rates, ratios, and conversions. Your objective is students will be able to find ratios and rates and convert units and rates. All right, so we're going to start with some vocab. First in ratio, so I know you guys have probably like had all this vocab. We're going to more so like tailor the definition to what it's going to look like in this class, okay? So ratio, we're going to say that it compares two numbers by division. So technically, I mean, it's just a comparison of two numbers, but if you look at the three ways to write these ratios, it can be written as a fraction, it can be written with like a colon, it can be written with the word two. We don't ever really look at those second two. It's always pretty much written as a fraction. So it's just basically saying if you divide those, you should get the same thing as like if you reduce the fraction, like 6/9 and then 2/3, when you divide those numbers together, you get the same thing, okay? Like the relationship between them is the same, okay? And then a rate is a ratio that compares quantities measured in different units. So you guys ever heard that that saying, like, you can compare apples to apples, but not apples to oranges? No? That's like a random like phrase. I swear to God, within the next week, you guys are all going to hear it somewhere now that I've said it, okay? But that's kind of what's going on here. So a ratio would be like apples to apples, like you're comparing the same thing. But a rate is like comparing apples to oranges. So like how many apples and how many oranges are kind of like equivalent to each other, okay? So like 5 apples for $2, or for salad dressing, $389 for 32 ounces, dollars and ounces, okay? And then a unit rate is basically a rate, so it's a rate with a denominator of 1. And what that means is it's basically when you have a rate that's per 1 of something, kind of like in the warm-up, how we looked at it instead of 12 cents per ounce, 9 cents per ounce, because it's per 1 ounce, okay? 60 miles per hour instead of saying 120 miles per 2 hours. It's just per 1, right? So this first problem kind of goes through and just has you look at the unit rates so that you can compare things, because we kind of need them to be unit rates, or at least be over the same amount of something to be able to compare them with each other. So we just basically do the unit rate. So we have 3 stores. We're shopping for t-shirts, and we're trying to figure out which store has the best deal. So in order to really figure that out, we need to figure out how much each store is charging per one shirt. So we're going to use division. Okay? If you have your calculator or need a calculator, either way, you need a calculator on your desk today. So either grab one to borrow, grab yours. If you don't have one yet, make sure you get one so we don't run out during class.
Oh my gosh.
I have a question.
Uh-huh.
Are we also doing, because I saw, I don't know if that's like a, but
That one's going to be tomorrow's assignment.
the 1.5.
So the 1.5 was Fridays.
Oh,
Yeah, so that was do 1.4, 1.5. So that's last week's calendar. If you're at the bottom, I haven't just changed it yet, so you can kind of see what, and then today's would start on the next Monday.
okay. Thank you.
Mm-hmm. All right, so for the first store, $25 for 2 shirts. So we're going to divide to figure out how much it is per shirt. So what would that be per shirt? Press the blue button, the corner, and then the number 1 right next to it. This is quit. Blue, and then quit.
Oh, okay. Okay.
All right, so how much is it per shirt on this one? Yep, so $12.50 per shirt. Okay, and then for store B, 45 over 4 is how much per shirt? And then what about store C? Yep, $10 per shirt. So now that you can see how much one shirt's costing, you can see which one's going to be the better deal. So what store is going to have the better deal? Mm-hmm. Yep. Store C has the better deal. Yep. And then once you're good on that, then just move on to that next one and answer that question, and then we'll talk about it after, but just don't say anything yet and just answer it yourself first. All right, so on the got it, so what's the new price? So $42 for 4 shirts. How much did it change? So how much per shirt? Yeah, so $10.50 per shirt. So is now going to be a better deal or no?
No.
Yeah, so no. Store C is still better. All right. Okay. Are we good there? Yep, all that vocab stuff. Okay, cool. So we're gonna move into like the main part of the lesson, which is conversions. So going into this, I just need to give you guys my little spiel. Today is going to be very much like I can do this in my head, is what you're gonna be thinking. I'm gonna show you how I'm gonna set it up, and you're gonna be like, yeah, nope, not doing that. I'm just gonna do it in my head. I can do it in my head. But then if you don't do it the way I'm doing it, all of a sudden it's gonna get hard at the end of the lesson, and then past that, and you're going to be so lost, okay? So think about it as like we all know how to do long division, correct? Yes? So if I were to teach you long division, I would start with normal division. I would say, okay, we're going to do 40 divided by 8. You guys know what 40 divided by 8 is, right? You can do that in your head. But does that mean that when we get to the point where it's this giant division problems and all of a sudden you don't know long division, like you're going to be lost? Do you know what I'm saying? Like I'm showing you the process with the baby easy ones, so you get the process, and then we're going to use it for the hard ones. So this is a skill that you are going to use in physics also. You're going to use it in chemistry all year long. If you can grasp and like get good at setting these problems up the way I'm going to show you how, then every single day in chemistry is going to be a breeze. It's going to be like one of the hardest classes all of a sudden turning into the easiest class that you're going to take because you just do it every day. That's what chemistry is doing the same thing over and over again, okay? So this process, like the way we're setting up these conversions, these are the keywords, dimensional analysis. So if you wanted to Google it, YouTube it, whatever, those would be the words that would like lead you to the right place, okay? And I'll just show you, like, I mean, the words are there if you will need a refresher later, but I'm just going to show you how to set it up. But the main thing that you have to keep in the back of your mind, it's like your mantra over and over and over again as you're doing this, is that the same units are diagonal, okay? If you set this problem up so that the same units are always diagonal from each other, then you set it up right every single time, okay? So just have an open mind, just roll with me, just do it this way and you'll see, I swear you'll see why we did this, okay? Because you're going to have problems that are going to be, you turn your page sideways, one problem's going to go across the whole page eventually, okay? All right, so we are going to first convert 330 minutes to hours. So when you're setting it up like this, you're going to start with your given, so 330 minutes. And for these simpler ones, before we get to the harder ones, we're just going to put a little 1 underneath as like a placeholder. Okay? And again, I know that lots of you can look at this and just do the multiplication or division and know what it is, but you're not going to be able to do that with the bigger problems, I promise. So just do it. All right, so the next thing that you're going to use, the next fraction, is going to be your conversion rate, which is basically what you would get if you were to Google or ask Siri or whatever, how many minutes are in an hour, that's what you'd get, okay? It's the thing that stays constant the whole time. So how many minutes are in an hour? 60. So that's what it's going to always go second, this conversion rate, and we're going to give it to you in the problem somewhere, okay? But you have to make sure that the same units are diagonal. So if minutes is on the top of the fraction here, diagonal would be where? The top or the bottom? The bottom, okay? So you're going to put your 60 minutes on the bottom, and then your 1 hour on the top. So now what you're going to want to verify is that your diagonal units, you can cancel them out, just the words you can cross out. Minutes are going to be gone. And your answer should be in this unit's hours, which is what we want. But otherwise, it's just normal fractions. So just multiply straight across, okay? So you're going to do 330 times 1, which is what? 330 hours. On the bottom, 1 times 60 is what? 60. And then you just want to divide that in the calculator. Five. 5.5. So you get 5.5 hours. We're going to do a couple more just to kind of get the process. Yeah. We did. Yeah. So you're talking about just doing the division in your head, which just log division? Yeah, that's fine. Yeah. I'm just letting you guys use the calculator on it so you don't have to like spend your time doing the work on it. But yeah, so that's basically what we did. Once we multiplied across, we ended up having to do division anyway. Yeah. Okay, so the next one, 15 kilograms to grams. So start with your given, 15 kilograms. I know it's such a pain in the butt, but just write out the units because you're going to want the words everywhere when you have the super long problems so you can look and visually see that they're diagonal, that it's all set up correctly, okay? Okay, then your conversion factor, so how kilograms and grams are related to one another. So there's 1,000 grams for every kilogram. But we just need to figure out what goes where. So if kilograms is on the top, where should it go next? Bottom. So we're going to use the 1 kilogram on the bottom. And 1,000 grams up top. Make sure your diagonal units cancel out the right way. Make sure your leftover unit is the unit that you were trying to get in the first place. And then just multiply straight across. So 15 times 1,000, it's going to be, or why did I try to do a money sign? That's weird. 15,000 grams. On the bottom, 1 times 1 is just 1. So our answer is going to be that 15,000 grams. All right, and this last one we'll try, 5 feet to inches. So start with your given, 5 feet. Okay, and then the relationship between feet and inches. There's 12 inches for every foot. Where's feet gonna go? Bottom, yep, so 1 foot is 12 inches. Cancel those out. We have inches left and multiply across. So 5 times 12 is 60. 1 times 1 is 1. So you get 60 inches. All right, does that make sense? Just a setup, you're able to just kind of draw it out like that. Okay, so go ahead and do that next one, that got it, and just make sure that you're setting it up the right way. I'm gonna come around, I think, and look to make sure, yes, before we move on.
Do I have to take this with me?
Yeah. Yep, it's your best. Just make sure your name's in the front of it, so in case you leave it, they know who to give it back to.
Do we do this one too, or just this one?
Just that one. Yep. Yeah. So so only you guys only have to do like the ones that say got it by yourself. And as soon as it says problem again, then you just wait. Yeah. Are we done with this one? Yeah. Okay. Cool. All right. So I want to come on and look, but I think you guys seem like okay. So I'm gonna do it. I need you guys to verify a couple things on your paper. Okay. Like pay attention. Otherwise, I'm gonna have to start coming around and looking. So I need you to make sure that your setup is correct. So like these are obviously in the right order. I need you to like have these units written out and show them canceling because this is going to get crazy where you have like 15 different units all being converted at the same time. So you need like to keep track. Okay. All right. So first, 1,250 centimeters to meters. So you should have 1,250 centimeters. Okay, and then your conversion factor, 1 meter is 100 centimeters. Where should the 100 centimeters go? Bottom, yep. So 100 centimeters, 1 meter. Centimeters cancels, so go across. 1,250 times 1 is 1,250. 1 times 100 is 100. And you divide that, so you get 12.5 meters. Okay, so just make sure that the units of your answer are the correct ones that you were supposed to be getting. Okay? You're not putting centimeters or just leaving it blank or whatever. All right, any questions where we're at so far? Okay, so now we're going to do a word problem together, a word problem on your own, try it, and then we're going to bump it up and do a harder example, okay? Like the next kind of step of this. All right, so problem 3. The CN Tower in Toronto, Canada is about 1,815 feet tall. About how many meters tall is the tower? And then gives you the conversion factor. So what are we starting with? 1815 feet. Let's put your little placeholder 1 in there. Then the relationship between meters and feet is right there. Where is meters going to go? At top, yeah? 1 meter, 3.28 feet. Feet cancel, you're left with meters and go straight across. So that's going to be 1,815 meters over 3.28. And then divide that. 553, you said? 0.3 what? Huh? Just give me one more number. 3.5? Okay, so let's do 0.4. So 553.4 meters. Okay, the next one is it's weirdly tricky. It shouldn't be tricky, but for some reason it is just because of what the units are. So you're going from dollars, like American dollars, to euros, okay? So go ahead and try that one, and then we'll go over it. You take like another 30 seconds or so. Remember that you guys have your homework page that comes after the notes if you want to start. All right, so let's go over this. So it says monetary exchange rates change from day to day. On a particular day, the exchange rate from dollars to euros was about $1 is equal to 0.63 euro. About how many euros should you get for $325 on that day? Okay, so what is our starting value?
325.
Yeah, 325. And this one's a little bit weird because like there's the word, it's like a symbol that we use typically for dollars. So like that. If it makes you more comfortable, you can just put 325 and the word dollars, okay? So you can like see the actual units. So now we're gonna use our exchange rate. which is this. So where is the $1 going to go?
On the bottom.
On the bottom, yep. So $1 and 0.630. So the dollars cancel, left with zeros. So you'll get, ooh, I don't know what that is. 204.75 euros over 1. So that's just going to be 204.75 euros. All right, so that's that. Do we feel okay on that one? Yeah? Okay, so now we're going to bump it up a bit, okay? So that's as far as you guys did like in previous years, right? Just converting one thing to another? Yes? Yeah, you'd remember if you guys did more with me. All right, so now we are going to do ones like this, and they even get way bigger from here. A student ran the 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? Round to the nearest tenth. So what makes this one different is that we're converting two things. So we're in yards per second, and now we need to be in miles per hour. Okay, so we're converting the distance units and the time units. So the way that we're going to set this up, I'm going to do it like the first period I showed them two ways, and they said that the second way made way more sense. So I'm going to just do it like that the whole time. Okay, so we are going to just start with the first conversion, so the 50 yards. And we're going to take that to miles using that rate. Okay, so 50 yards. Do not put the 1 underneath it though. Okay, or save that space. And we're going to use our conversion factor, which is miles to yards. Where is yards going to have to be?
On the bottom.
The bottom, yep. So 1,760 yards is equal to 1 mile. Okay. Good so far? Okay. So that's going to get rid of our yards because they're diagonal and leave us with miles, which is like the first half of what we need. Okay. So now what we're going to do is we're going to convert the second one. So it's 5.8 seconds. We want that in hours. And then there's our seconds to hours conversion. Okay? So what we're going to do is we're going to do our 5.8 seconds, but we're going to put on the bottom. And then we're going to tack on another fraction. So since seconds now is starting on the bottom, where should it be in the next one? The top, yep. So you're going to do 600 seconds is 1 hour. So it's like you're just kind of layering two problems on top of each other, okay? So now the seconds cancel, and we're left with the hours. So if we look at our units, we're left with miles per hour, right? Which is what we wanted. So from here, it's just the same thing. Go straight across. Just multiply all three in the top together and then all three in the bottom together. So what you should get in the top is 180,000. 180,000 miles. And then on the bottom, multiply all that together. 5.8 times 1,760 times 1. You should get 10,208. And then just divide those numbers together. Mm-hmm. 17.63. Correct. Yeah. So we'll just do 17.6. 17.6 miles per hour. Okay. So does that kind of make sense? So like the first conversion is going to be the blue, then the second one's going to be the red. So either your distance, blue, time red, whatever you did over whatever you did. Okay? So go ahead and try to set up the second one. Get as far as you can. If you don't get all the way through, that's okay. Like this takes practice and time. Okay? But once this clicks, what's nice about it is that it doesn't matter how big the problem is, you'll be able to get it, and it's not going to go out of your brain. I take like 1 more minute.
Would I round that to 22?
Yeah, I did. Yeah. All right, ready? All right, an athlete ran a sprint of 100 feet in 3.1 seconds. At what speed was the athlete running in miles per hour? Round to the nearest mile per hour. Okay, so first is we have to convert feet over to what? Miles, yeah. So we start with 100 feet. And then, so that means feet should be on the bottom. So you have 5,280 feet is 1 mile. Okay. So this goes away, and we're left with miles. All right, next we have 3.1 seconds, and we're converting that to what? 3.1 seconds. And we want then hours. Okay, so seconds is on the bottom, so where should it go?
The top.
Top, so 3,600 seconds is 1 hour. And you can kind of notice too, like hours is on the bottom, and the answer miles per hour, hours would be on the bottom. So that makes sense, okay? So that cancels. Hours. All right, so now multiply the whole top together. So was that just 360,000? Yeah. And that's miles. On the bottom,
16,368.
16,368 hours. Divide that, and it's like 21.99 something, so that you should have 22 miles per hour. All right, got it? Okay, so these just, if you can master these double ones like this, you'll be straight, okay? And then in chemistry, you'll bump it up, but you're not gonna notice the difference because now that you know how to do multiple, you just carry it on, okay? Cool, so here's your lesson check. So the first one, you don't have to write down the problems if you don't want to, because you have access to these on Google Classroom. You can always pull them up if you needed to read the problems, okay? So just do the problem. Which is the better buy, 6 bagels for $3.29 or 8 bagels for $4.15? What is 7 pounds converted to ounces? So that's just your single conversion with the 1 on the bottom. And then a car is traveling at 55 miles per hour. What is the speed in feet per second? Okay, that's your double, like we just did. Okay, so go ahead and get those done. Again, you do not necessarily have to write down the problem. You have access to these notes, or you could go look at the problem again if you had to. Okay, just tell security that. And make sure you have your ID with you.
Huh?
Make sure you have your ID. Bless you. And guys, once you're done with the goddess, you can start working on homework, and then I'll put the answers up once. That seems like most people are done.
I have a question.
Mhm.
So, it says miles per hour. Would it be miles? Is that what I read it as?
For the bottom one,
No, for the
number 3.
Yeah,
Yes.
Yeah,
Yep. Yes. So on the top, you'd put 55 miles, and then and you'll save the per hour. That would be 1 hour on the bottom when you do the second time.
Okay.
Yeah. When you do the other conversion, the rent conversion.
Thank you.
And are we ready for answers on these 3? Yeah? Okay. All right, so for number 1, the better buy is the 8 bagels for $4.15. So on those, anytime that you're dealing with like money, and maybe it's just opposite in my brain. I'm off with these in my head, but you always want to do the money first, like the money on top. So it's like, because you want to figure out how much money per one bagel, 1 ounce, whatever. I always try to do it opposite, and then I realize like that doesn't make sense. Okay. You do, but you have to do $4.15 divided by 8, not the other way around.
That's what I did.
Are you sure?
And I got $1.92.
No, you did it the other way. Yeah, you did 8 divided by 4.15. Yeah, I know. I always try to do it that way, that like the way that it comes, but you have to do the money on top. Otherwise, what you got, the 1.92, you can get 1.92 bagels for $1. Is what you got. Yeah. I know, it's weird. Okay, so the number 2, you get 112 ounces. And then number 3, 80.7 feet per second. Do you want me to look at that one?
Yeah.
Okay, yeah.
Write it out.
Yeah. So I'm going to do this on the back, okay? So maybe we'll find out that this is wrong. The answer is nobody's ever caught it. That'd be cool. All right, so 55 miles per hour. And we're going to what, feet per second? Yeah? Okay. So we're going to start with the 55 miles. Okay, what was it? 1 mile is 5,280 feet. Okay, so you should have the 1 mile on the bottom. 5,280 feet. Oh, yeah. Yeah, so remember, like the thing that you always want to keep repeating over and over again is the units have to be diagonal. As long as you check and see that the units are always like on opposites, then you know that you got it right. Make sense? Yeah. Like you shouldn't have like 2 miles in the same row. Okay. All right, and then for the next part, hours. So hours is on bottom, so you have to put it up top. Hours and seconds. 1 hour is 3,600 seconds. Hey, Dobbertron, what class does this look like? What class do you do this in?
What class does it look like?
Yeah. What class you take last year that you did like the conversions like that?
Yeah, we did this last year.
In what class?
In Algebra 3-4.
Oh, you do it then too?
Huh?
You do it in Algebra 3-4 also?
Yeah.
Oh,
Yeah.
I didn't even know you guys
like
did
we're
that.
like we're converting.
Yeah, and then do you guys use this in chemistry at all? When you're like
Yes,
moles
yes,
to whatever?
yes,
Yeah.
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 So,
Mhm. Like and where you have to find like on the periodic table like the weight and all that.
those are the questions I mainly missed.
Yeah. See, I told them I was like, you use this every day in chemistry. If you don't know how to do this, you're screwed.
No, it applies to chemistry
Yeah.
easily.
All right, so these cancel. So you have feet per second left. So we multiply that. I don't know. I know at the bottom. Hmm?
The top is,
Is that 290?
yeah, 294.
290, 400 feet. And then when you divide that, is that 8.7? Do you guys verify when you divide? Just make sure that the answer's even right.
Yeah.
Yep. Okay, so that's 80. All right, does that make sense, guys? Setting it up like that? So I always take the extra time to just cross out the actual unit, circle that, make sure that feet per second is what you end up with circled before you go through the whole thing. Okay? There's a question over here. Question? Okay. All right. Cool. So you guys have 5 minutes if you want to do maybe go to this section on the homework and do one of the hard ones. So that way if you do have questions or want me to look at it